Welcome everyone to today's workshop led by Rob Coward, who will be delivering a workshop on cloud migration optimization. Rob, if you can just go to the next slide, please. For those who aren't aware of WeShape, I'm one of the directors of WeShape. We're a DevOps cloud native consultancy in London. So we support businesses anywhere from kind of technical organizational advisory, right through to kind of implementation solutions, whether that be kind of project squads or on-demand consulting, consultants, and also training solutions. Here are some of the kind of customers we've worked with over the kind of past 2 years. Rob, if you go to the next slide, please. Yeah, I guess in terms of kind of more detail is we typically are engaged at the earlier stage of maturity of your kind of technology transformation, whether you need kind of guidance around predominant technical or organizational structures for your digital transformation. We have two kind of implementation models, so that's squad solutions, so pre-gel teams we deploy for product delivery, or SME consultants where you might have a typical technical capability gap. But one thing we're huge advocates for is about self-sufficiency. So how do we train and upskill your in-house capabilities to make you self-sufficient in the longer term? Rob, you go next slide, please. One of the key differentiators for WeShape is we're heavily invested in the technology community. So we're behind the London DevOps network, which is about 8,000 plus open source specialists, hosted monthly. So really good opportunity and platform to share kind of what your organizations are delivering from a technology perspective. Or if you're looking to speak and share some of your learnings, we're always open to future speakers and hosts. And on a leadership capacity, we're behind the London Tech Leaders event, which is a 1,000 plus CIO, CTO network, where we host quarterly events, have a content platform where you've got the latest articles, blogs, podcasts, from some of the most inspiring kind of leadership executives across the market. So if you're ever interested, please do check our event community out. And if you're interested in speaking, drop us a note. And last slide, Rob. Yeah, I guess tying into everything else I've just mentioned is we think it's a huge value add to kind of run these workshops. One is to give you a flavour of kind of where our expertise sits in the market and confidence in terms of kind of what we provide from a consulting perspective. But some of the key reasons we engage or are engaged by our customers is one, to kind of guide and shape technology strategy, whether that's process tooling methodologies. It's to come in and accelerate and bootstrap kind of product delivery. So whether you haven't got the kind of technical depth or competency or just need a kind of third party or third person opinion to give that kind of incremental guidance. And then the key thing is we've obviously operate in a very in-demand sector. So it's about upskilling your internal capabilities and making sure your team are confident leading the journey thereafter when we phase off site. So yeah, if you're interested in understanding more about WeShape, do drop us a note. We're always here to kind of help and see where we can provide the most value. But I'm going to pass over to Rob, who's leading today's workshop on cloud migration optimization. Rob, over to you.
Thank you, Chris. So without further ado, let's have a look at what we've got today. So I'll introduce myself. I am an IT consultant. I have been working in the industry for over 25 years, and I've worked across most of the different sectors, different verticals that you might think of, ranging from petroleum to finance to healthcare. But most recently, I've been working in the fintech area, working with a number of different banks, different investment houses, and so forth. So I've got experience with software delivery, started out my career as a developer, moved more into operational deployments, automation, and when the term DevOps came along, that kind of described what I've been doing for the last 15 years. So sort of now known as a DevOps consultant. So let's have a look at what we're going to look at today. So we're going to start off by level setting. What do we mean by the cloud? We're going to look at how we can then effectively use those cloud services to bring value to your business and to improve customer outcomes. We're going to look at how we can migrate. So I'm assuming most people are joining and they're interested from moving from a traditional on-premise IT infrastructure to leveraging cloud and the abilities you get from the cloud. So look at how you might lift and shift existing deployments, and then benefits of redevelopment, and actually looking at how you can leverage microservices, containers, loosely coupled architecture, and benefits that you come from that. And then we'll lastly just touch on some elements of automation and DevOps and SRE, although we're not going to go too deeply into those because there are a number of other workshops that you can join, including benefits of SRE, which is another workshop coming up in a few weeks' time with the WeShape workshops. So what is the cloud? At the end of the day, it's just someone else's data center. You're used to running infrastructure in your data center. The cloud is just someone else's data center. That's the crux of it. The vendors have a number of different services which can be consumed, and we're going to have a look at the structures and the formats in which those services are offered as the first section of this workshop. The benefit of to a lot of the financial elements, the financing and your finance departments, is that cloud is an operational cost. It's not a capital cost. It's not an investment. It's not, depreciating hardware which you have to purchase with like a 3 or a 5 year mindset and buy something that's going to last that long. It's something which you pay for right now, and when you stop using it, you stop paying for it. It's really good for rapid experimentation, for prototyping ideas. And, if it doesn't work, great, throw it away. You haven't got that tie into, the physical bit of hardware that's racked up in your data center, which is going to now cost you for the next 3 years as it depreciates and so forth. Benefit of as well that someone else's data center, or data centers more likely, is that they're going to have a very geographically diverse set of infrastructure which you can then leverage. It's unlikely you're going to go to any cloud vendor that doesn't have some kind of geographic spread within your region or around the entire globe. So there's lots of benefits to the cloud. But let's start off by sorting out what we mean by the cloud. So the National Institute of Standards and Technologies defines a number of key characteristics of how you describe a cloud. The first one is on-demand self-service. A consumer should be able to provision compute capabilities such as server time, network capabilities, storage, as they need automatically without requiring any human intervention. So if you're used to working in a data center environment or working with managed service providers, you'd be used to filling in request forms, or going through the purchasing system to acquire new hardware and stuff. That you don't have that with cloud. It's all on-demand self-service. You can do what you want when you want to do it. The second characteristic that they define is broad network access. That means all of these capabilities are available across the network, whether it's across a mobile network using 3G, 4G, 5G network connectivity, broadband, anything which is internet connected or through standard network connectivity, you've gained access to these services. Resource pooling is a big one because it allows the service providers to provide a multi-tenanted model where they have all of their servers racked up, they have all of their storage and their investment in the networking and everything, and you then shared a portion of that, and as you need more, you can grow that portion of it. And it can often seem like there's an infinite pool, and as you want more resources, you just request it. Now, obviously, it is in a physical data center. There will be limits within that provider's servers and resources they have, but often to a consumer, it seems like an infinite pool of resources. Rapid elasticity, as I just mentioned, one of the key features is you need to be able to consume and shrink and grow your resources as you want. And this again is key to the concept of cloud. no longer are you tied into having to request and have lead times for new resources and have new servers racked up, or go through a 6-week lead time of purchasing and acquiring new hardware. Elasticity, automatic scaling on demand, giving you the resources you need when you want it, and when you don't want it, shrink it back down again. And then the last one is measured service. All the cloud providers will offer a metering system. They will know how much you're using, and you'll get billed for how much you use at the end of the day. And often that is down to per minute metering. Some of the providers, I believe, always also now offer per second metering. So if you're only using a compute resource for a couple of hours, you only get charged for that couple of hours of usage for which you're using it. And this is really key, because that's one we'll have a look in a minute. It's one of the ways you can save costs within your business. So the different types of service models that you'll see within a cloud environment. The most common one you'll hear is infrastructure as a service, and we'll have a look at how this breaks down in a minute. But essentially, you are being offered compute resources, you're being offered a server, you're being offered network, you're being offered storage, and you consume that as a service. You can deploy onto that compute resource whatever applications you want. In that respect, it's the closest model that you have to your current data center traditional IT deployments. Oops, wrong way. The next service model is platform as a service. And this is taking a little bit more of control away from you, but it's giving you less responsibility in terms of managing the underlying infrastructure, but gives you a platform which you can then layer your application on top of. The next level is then software as a service. And I think without doubt, the one that most people will be most common with is things like Office 365 or Jira Cloud Service or GitHub. These are all examples where that service provider is running their own software, they're running it for you, and all you're doing is consuming their software. So, you know, you might want to host your own Git repositories in your own data centers, or you could actually just pay GitHub to host that repository for you. You don't have to worry about the storage, you don't have to worry about backing it up, you don't have to worry about the resilience of it. That's all taken care of by the service provider. You'll probably find there's a number of other as a service type phrases that you've heard coming up as you've maybe been reading around the subject of cloud and cloud capabilities. You might have heard of database as a service, function as a service, security as a service. There's lots of these things that have been coming up and being used by marketing to sell the concepts. At the end of the day, most of them, what they're talking about really is software as a service. They are providing you with their software. You have a logon credentials to be able to consume that service, and that's the crux of it, really. So let's break that down a little bit further. And all of these clouds have a concept of a shared responsibility model. In your traditional IT deployments, you have a stack of resources which put together and construct your application stack, starting forgetting physical data centers and the cooling and the electricity requirements that are stored, you know, to actually bring up this infrastructure. You have a networking level, you then have storage, you might have a storage area network, you might have network attached storage. You then have your servers that are built on top of that. You probably have some form of virtualization, might be Zen, might be VMware, a number of different options there. On top of that, you then lay your operating system, any middleware, might be JBoss, might be your message queuing system, Java runtime possibly, or Node.js, and so your runtime elements. Then you've got your data, and on top of that, you finally have your application code. And all of that you have to manage. You need to have the expertise, you have the knowledge sets, the skill sets to be able to handle everything in that stack. So if we then look at the first model, which was infrastructure as a service, the first half of that stack is all delivered for you as a service by the service providers. So they take care of the networking, they take care of the storage, the servers, any virtualization sat on top of the physical servers, and to a degree, and we'll come to this in a second, they take care of the operating system. So they will offer you a CentOS image, a Red Hat image, an Ubuntu image, a Windows Server image, and you can choose those operating systems and just deploy it. Come back, sorry. On top of that, you then deploy your middleware, your runtimes, your data, and your application code, and then that's what you manage. So you can see already, using infrastructure as a service halves that technical stack of skill sets that you need to have to maintain that application, to actually deploy that application, get it out into the world, and to actually serve your customers. The OS is in the middle there, though, because while infrastructure as a service will deploy a server or multiple servers for you of the operating system of your choice, once that server is running, that becomes your responsibility. So you're still responsible then for OS patching when there are security updates need to be done and so forth. That's still your responsibility. So that operating system is halfway between delivered as a service and what you manage. We go on and look at platform as a service. Even more of that stack is delivered to you and managed for you as part of the service that these cloud vendors will offer. So they will take care of everything that you had with infrastructure as a service, but they will also take care of the middleware and the runtime. So all you need to tell them is, I want to deploy a Node.js application, I want to deploy a Java application, and they will provision the necessary underlying infrastructure, the Java runtime environment, the Node.js executions and so forth. And all you then need to upload is any data that's required and the application code itself. Now, Cloud Foundry is probably one of the most well-known platform as a service elements here. You also have tools like OpenShift, which have a similar concept where you just point it at your Git repository. Anytime you commit new code to that Git repository, you'll get a webhook fired to your platform as a service. They will pick up that new version of code and can automatically then deploy that out into the environment for you. And then finally, the third model, software as a service. And this is where that whole stack is taken care of for you. You don't have to worry about the data, the application, backing up your data. So if you're using something like GitHub or Office 365, all of that, all you need is credentials, you log in, and then you consume that system. So if we move on and have a look at the different types of deployment models, first of all, you have what's called private cloud. Private cloud is infrastructure that is provisioned for exclusive use by a single organization. Now, it might be made up of multiple consumers, like business units within that business, but it's still just that single use, single organization using it. It may be owned and managed by a third party. It might be hosted in your own data center still. There's software such as OpenStack, which allow you to host your own private cloud on your existing infrastructure, your existing resources you might already have racked and stacked in your data centers. But then a lot of like the big players, the managed service providers, can also offer you a private cloud system for you to just log in and consume. Then you've got community cloud, which is a step further from that. It's where you've got a specific community of consumers. So it's not just a single organization now, but it might be people that share common elements like access to healthcare data, public sector organizations. If you need a higher level of security clearance, classification around the data which you consume and that you manage. Another example there, community cloud for Salesforce. You have a community of Salesforce related consumers and organizations there. There are others. These are just some of the people I've worked with in the past. Then you've got public cloud. You've got your common big three. You've got Amazon Web Services, Microsoft Azure, Google Cloud, but there's a lot of other providers out there as well, which also provide public cloud services. Many, many more than what I can fit on this slide here. Lastly, you've got this concept of hybrid cloud. Now, hybrid cloud is a combination of two or more of these other types of cloud, often used for bursting capability or basically allow your movement of application and data, the portability between the two different deployments. So you might, for example, have a private cloud on premise where you have the bulk of your backend systems, but then you might have an element of public cloud where you host your public facing services. You might have a community cloud where you have some public sector elements, for example, backends going through to HMRC to collect your tax records. But then you might also consume some public cloud for the public facing HMRC websites, as an example. So there's lots of different things to think about if you're looking at moving to the cloud. It may be your first steps are just to think about private cloud and have some form of utilization of your existing hardware, but to give your consumers, your business units, your developers, a better access to those resources using the self-service and the metering and the elements we've looked at in previous slides. So when it comes to using cloud services effectively, I've got three pillars which we'll look at in more detail. The first one is it gives you an excellent way to reduce your costs. You only pay for what you use. Now, obviously, if it's a private cloud, if it's running in your own data center, that's kind of not so relevant. But if you're in a public cloud and you're being metered by the minute, by the second, then if you're not using it, you're not going to pay for it. Also, when it's a public cloud, it's going to come out of your operational cost bucket when finance have to account for this in the end of year wrap up. It's not a capital cost. It doesn't have any depreciation of assets that you need to factor into your accounts at the end of the year. Clouds allows you to increase your productivity. It's very quick because it's self-service to consume new elements, and it's very quick to throw them away again. And because of the nature of it's someone else's data center, you can choose your service provider with the kind of coverage that they offer. So they may have data centers all around the world. They will provide high availability and fault tolerance as part of those services. So let's dig into that a little bit first. So for reducing costs, one of the things that a lot of people do when they're sizing their infrastructure, because they're used to having this concept of capital expenditure, reducing the assets, having depreciating over time, you have to size your hardware to allow for growth. You don't need to worry about that with the cloud. You pay for what you use now. So you only use what you need to use now. You don't scope your servers for capacity in 5 years' time. You don't scope your servers for capacity in 6 months' time. You size them for what you need today. And then you only pay for what you use today. So sizing is very key when it comes to reducing costs. You only use a big enough server to deliver the infrastructure and the services that you need today. Key to that then obviously is monitoring that infrastructure. So know how it's being used, know when you need to increase that capacity. And monitoring is so key to cloud usage, not only in terms of its usage, but also to be able to keep a rein on potential spending. With self-service, you then often have the concept of, wow, I can spin up as many servers as I want, but then I leave them running, and that costs money. So if you've got monitoring in place, you can see when there's maybe a sudden upturn in the amount of expenditure that you're being billed for. You can see the amount of compute power that's being used. And if it's not being used because it's idling at 5% usage, then you can scale it. And you can use the elastic nature and the capabilities of cloud to scale that back down, to bring it back down to a level where you're only using what you need to use. But in the concept, conversely, you can also scale it up again. So if you see that your resources are being overused, maybe overcommitted, then you can scale up and use that elastic nature of the cloud to increase your footprint in the cloud and actually get more out of it. Another big thing in a data center, apart from the fact you're paying for electricity and the cooling systems and things like that, people don't really think about turning off servers. If it's a non-production system, if it's only being used, in office hours, doesn't matter. In the cloud, if you're not using it, turn it off. If it's a non-production environment, if it's a test environment that only needs to be used during office hours, turn it off. And then overnight, you won't be paying for it. Now, there is still going to be a small cost involved if you're keeping your servers around but just turned off, because you'll get charged for the storage on the disk space. But in terms of percentage-wise, most of that cost comes from the compute and the number of hours or days that the servers are left turned on. So if you've got some non-production environments, test environments that don't need to be on 24/7, turn them off. Most clients I've worked with, we have set up like time-based, cron-based systems, which allow you to, after say 6 or 7 p.m. at night, just shut down all of your non-production systems. And then 6 a.m. in the morning, turn them all back on again. And that way, when someone comes into the office, say 7 o'clock in the morning, 8 o'clock, 9 o'clock in the morning, they don't know it's been down overnight. It's just saved you 12 hours of cost and stuff. So really powerful thing with the cloud. Only keep the servers on for as long as you need them. And that brings me on to the last one here. If you're not using your servers, throw them away. You don't need to just turn them off, just get rid of them. And this is even more so when you're dealing with like build infrastructure, CI/CD. You've got a build server which gets a webhook notification that someone's committed a new bit of code. You need some build resource to be able to then compile that, create your build artifacts, kick it off down the deployment pipeline. But then when that job's done, you don't need to keep that server around. Just terminate it, throw it away. Most of the build systems now will have interactions with cloud service providers, and they can dynamically create the resources they need to run that build job and then terminate it when it's done. Jenkins is a CI/CD tool, very common. Lots of people love to hate it, but it's got so many plugins, so many integrations with the different providers, different cloud systems. It will dynamically create a new build agent when a job starts, runs its job on the agent. When that job's finished, terminates it, shuts it down. And there's a lot to be saved there in terms of only using that compute when you need it. So productivity, it's self-service. So being self-service, you can get access to the resources you need when you need it. One of the biggest headaches of working in the old IT infrastructure world is you have to request the resource. It might be that you're requesting resource from a managed service provider. You might be requesting it from another department. You might have to even purchase some additional physical hardware. There's lead time with all of that lot. That slows you down. When you have access to self-service infrastructure, there's nothing slowing you down. You can get on, you can do what you need to do, and you can create those servers on demand. You can create what you need, you can create it when you need it, you can create it the size you need it, and you can get going. Because it's managed infrastructure as well, a lot of that stack, as we looked at in the shared responsibility model, is managed for you. So you don't need the expertise to actually stand up a new server. You don't need someone with security clearance to go into the physical data center to rack and stack a new bit of hardware, to cable it all up and to do the underlying networking. That's all taken care of for you. You don't need to worry. All you need to do is use whatever portal self-service interface that's provided and say, I want a new server. I want it to have this bigger resource pool. I want to have an extra 200 gigabytes of storage and have fast network connectivity. And it just does it for you. Most of the time, you'll have that server within minutes, and then you can be getting on with what you really want to be doing. Cloud services also gives you very quick access to trial new technologies. Now, if you are wanting to try an experiment with something new and you're working in the traditional IT infrastructure, again, first thing you'd have to do is request new resource. You might need a new virtual machine creating. You might need, even to go to the extent of purchasing some software or something like that. Most of these cloud providers will have a large catalog of applications, of different tools, different software that you can just choose from a catalog and deploy. And if you want to deploy a new firewall, if you want to deploy a new application stack, if it's an open source tool, great, it will just charge you for the cost of the server. If it's a commercially licensed tool, most of the service providers will have agreements with these various applications and actually bundle that license cost for you. So if you wanted to create a Microsoft SQL server, the cost that you get charged by that service provider will include the necessary licensing for the SQL server and the cost of the actual compute. So it makes it very quick to gain access to some of these new tools, new technologies, to try something new. And when you've got access, you can then very rapidly prototype new services using these managed underlying tools. You can very quickly have teams working in the laboratory, testing out ideas, putting together something new, going out at the weekend, trialing that with live customers, taking a tablet out into the branches, into your stores, and showing people, a new version of a website or a new tool for managing their credit card or for ordering systems online and things like that. Because you've got access to all of these things on demand, you can do this. And then, you get feedback. The following week, you go back into the lab, think, well, I'm going to tweak this, I'm going to change something else, and then go back out the following weekend or the next day even, and show a different element to your customers. And then you can tweak that and you can tweak that, and that just helps with your productivity and improves your customer outcomes. And then when you're all done, throw it away. You haven't got expensive hardware tying up, rack space in a data center. You just flip off the switch and say, I'm done, delete it. And that's when your billing ends. You don't get charged any more than what you use. So if we then go on and look at the availability, the third pillar that I showed you, this is where it really glows and you can really benefit from the cloud, because without doubt, cloud vendors will have multiple data centers. They'll be geographically spread around your region, around the world. The big players, especially public cloud, will have facilities in every continent spread around the world. And you can leverage that. You can leverage that resource pool that they have invested in and make the most of it. If you've got an application that is time sensitive, that is latency sensitive, you can choose to deploy your application in one of the cloud vendors' services regions close to where those users are going to be. If you've got regulatory requirements that you have to keep the data in a particular country, you can do that. You can specify that you're going to build your servers within the EU or within the US. And that's great. You don't have to then go and provision your own data center and set up racks of servers in another country, just because the US laws might require you to keep the data in the US and not host it back in the EU or in the UK. Likewise, if you're looking to expand globally, leverage the cloud. Use the fact that there are data centers run by these cloud providers all around the world. If you're looking to get into a new market, maybe out in Australia, out in Asia, go and deploy your servers out in those data centers that are run by the cloud providers out in Asia. And then those customers will have the benefit of nice, fast access, low latency access to the services that you're providing. One of the customers I've worked with in the past was providing a voice over IP system, telephony in the cloud. And telephony is notoriously sensitive to jitter, to latency in the network connectivity. So, applications like that, you really have to host close to your customers. It's no good trying to run some kind of telephony service that runs in Australia if you're in Europe, because the latency involved is going to be horrendous. High availability of your infrastructure. So this is really key. In the old IT infrastructure world, you'll be used to having a concept of a primary and a failover data center. You'll have a disaster recovery plan. You'll probably have an annual or biannual test of that disaster recovery plan to make sure that if one of those data centers has a problem, you can fail over all of your systems into your second backup data center. When you're dealing with a cloud, disaster recovery is not really so much of something you need to worry about, because every cloud provider will have a concept of failure domains, sometimes known as availability zones, sometimes other terminologies used, but you can probably align your thinking to one of these availability zones or failure domains. It's kind of equivalent to one of your data centers, and they have hundreds of them. Typically within one region alone, and I'm talking certainly with the big providers, Amazon, Google, Azure, they'll have multiple availability zones within one region. Within Ireland, you'll probably have 3, 4, maybe 6 different failure domains or availability zones. And so you can use that in your architecture to build a resilient, high available system. You can even deploy across multiple regions if you want to guard against the whole of one area going down. If you know, heaven forbid, there be a massive power outage that takes out the whole of London, and you don't want to rely on just one region, you want to have a backup over in Frankfurt, for example, you can do that. All of these cloud service providers will have their own underlying infrastructure which interconnects all of these regions. And so you can leverage that when deploying across multiple zones within one region, or even across multiple regions. You can even go multiple cloud vendors. So not have all of your eggs in one basket, but have some services provided by one vendor and some by another vendor, or set up the infrastructure where you have a sharing mechanism where you have services provided by multiple vendors. Then lastly, you've got fault tolerance. Now, because the underlying infrastructure is all managed by the service provider, they will have high SLAs, which they will stick to. And then it's down to you to architect your own infrastructure, your own applications to leverage that resilience, the availability, the multiple regions, and ideally build in self-healing. You want to make sure your monitoring will trigger ideally self-healing, if not call outs to your on-call teams. But have the ability to then move that service around between different failure domains, different regions, and so forth. So you've got a lot of scope there, because these vendors, they've already done that investment. They've already built out these different data centers. So when we start talking about migrating traditional infrastructure, most of the time we're going to be talking infrastructure as a service. We're talking about that first stack that we talked about, where the cloud service provider is dealing with the underlying network. They're providing the storage, they're providing the servers and virtualization, and they give you a menu to choose from in terms of what operating system you want to deploy. So when you start thinking about that migration initially to the cloud, a lot of the traditional concepts you might have built in your on-premise data centers, you can still do that. You can still have internet-facing services. You can have a DMZ area. You can have a private area where you have your back-end systems running, which aren't exposed to the internet. You can still do all of that when you're running in the cloud, especially when you're using infrastructure as a service. But the bottom half of that stack is taken care of for you. You don't need to worry about the network. You don't need Cisco qualified engineers to set up your Cisco switches and your routing and everything like that. That's all handled for you. Instead, what you provided is what's known as software defined networking, or SDN, where you can very easily, through some simple menus or API calls or automation software, define what subnets you want, how those subnets are interconnected with route tables, how you might want to then link that back to your on-premise systems via VPN connectivity, IPsec, tunnels and things like that. And all of that is very easily accessible via user interfaces, pardon me, or via automation and API calls. Likewise, storage is taken care of for you. You don't need to worry about setting up a storage area network. You don't need to worry about network attached storage. All of that is taken care of for you. All you say is, on my server, I want to have an additional 200 gigabytes of data storage defined, and it does it for you. It will decide where it hosts that physical storage. It will then expose that storage to your operating system as a device, and you can just consume it and mount your file system on there. A lot of cloud providers will also have integrated identity and access management, or IAM, as you'll see an acronym used. That allows you to integrate their user credentials, which you use for connecting to their systems, and using that to authenticate access to a lot of these other resources. You will often have ways of setting up different levels of access so that not everyone, for example, may need the ability to create new resources, but you may need an operations team to have edit access to be able to monitor and update an existing deployment. So you can set up various access requirements and stuff within there. And again, as mentioned, often there'll be requirements to connect back to your legacy infrastructure in data centers. And there's many different ways this can be achieved. The most simple way of setting up is some form of VPN tunnel using IPsec encryption and so forth. But a lot of the big cloud providers will have other options. You might have the option to set dark fiber links or run wire level connectivity to co-hosted locations. If you happen to have your hosted infrastructure in the same physical data center as one of their points of presence, it may be a case of just running a wire through the data center into a patch panel, and then you get full 100 gig, 10 gig, 100 gig, whatever network speed access into their infrastructure and through into the environment which you're providing and provisioning in their infrastructure. So what would we typically do to start off with? Well, first thing we need to do is think about what network we want to define. This is the software defined networking, which although the underlying physical network is managed, you still need to think about a network. I would always recommend from the outset, we start off with an isolation between public and private networking capabilities. All the cloud providers will have the ability to set up the separate subnets within the environment they provide for you. You may or may not have an internet gateway. It may be that it's completely isolated from the internet and you just have connectivity back to your on-premise data centers, your on-premise resources. If you do have an environment where you're using internet connectivity, you might have a NAT gateway, which allows access for servers that are in the private area to gain access out through the internet and so forth. I would also say from the start to make use of availability zones, of the failure domains that your cloud provider offers you. Most will have multiple zones within the one region. I don't think there's any Amazon regions, for example, that have less than 3. Some have 6. And likewise for many of the other providers. So as a minimum, I would always start with 2 availability zones and think of it in the kind of way of 2 data centers where you're used to having a primary and a failover, but then throw that idea away. Think about whether you need to connect these resources back to your on-premise existing resources. What sort of WAN connectivity are you going to need? Is it sufficient to rely on a VPN tunnel, or are you going to need to look at something a little bit more substantial if you've got various latency sensitive applications that need fast access back to maybe an on-premise Oracle data center or some other data store? You maybe need to look at that. And you want to think about sizing your network address space for growth. Now, this is software defined and it's very easy to define a new network, but because of the way the underlying network protocol works, you can't easily grow an existing subnet. You can add a new one, and being software defined as a service that's offered to you by your providers, you can do that. Not so easy to grow it. So think about how much you might want to grow, how many extra servers you might want to provision, and then allocate that network CIDR range accordingly. Key thing, think about your networking. You can change it later on, but it will often involve downtime. You'll need to take any servers that are in those subnets down to be able to resize it and then bring them back up again. And that's not always something you want to necessarily do, especially in a production environment. So it's worth thinking about that network element ahead of time, and how much space you need and how big a CIDR allocation you're going to have within that environment. Then you get to choose what servers you're going to deploy. Now, almost without fail, most cloud providers have gone with this concept of a t-shirt sized setup. It makes it easier for you, makes it easier for them to bill you. And basically you've got this concept of like a medium, large, extra large, 2XL, and that then aligns with how many cores it's got, how much memory it's got, how many gigabytes of ephemeral storage that might be associated with that server. So you get to choose what size server you want to deploy, and you get to choose what operating system you want to deploy on that server. It might be an Ubuntu server, it might be a Microsoft server, it might be a Red Hat Enterprise server. You want to say where you want to deploy that server. Now, it could be an internet-facing web server. That's great. You pick the public zones. It might be you're putting together some kind of backend data store, which you want to put on the private servers. But what you can also do is you can say, I want to spread it across 2 zones, so private A and private B. And when you create your servers, it will then round robin and balance the number of servers across those 2 environments, which is great. Cloud use a concept of a security group. Now, you could think of it like a personal firewall. In traditional IT, you have a boundary where your subnet, your network, has a firewall which prevents access coming into that subnet from anywhere else. It might be network access control lists, which specify which other networks can route traffic in and out and so forth. And you can do the same thing within the cloud. The security group concept, though, wraps around 1 or more servers. So you can have a web server security group, for example, and you can apply that security group to all of the web servers. Now, because this is cloud, the servers might be coming up dynamically. You don't necessarily know what addresses they're going to be allocated, but you can still use a security group around the servers, whatever their addresses are. And that can define incoming traffic, is what the traffic's allowed. You can define what outgoing traffic's allowed. So you might allow HTTPS traffic coming in from the internet. You might allow traffic going out to your database servers. Likewise, with your database servers, you probably only want to allow the connections to come from the web servers. You don't want to allow connections coming from anywhere else. And security groups are a great tool because you may not know what the actual IP addresses of your web servers are, but you can put in your database servers group, say, allow connection from the web servers group. And it doesn't matter what the actual addresses are, it works it all out for you. So think of security group as like a personal firewall on steroids. You can then specify any additional storage. So if your web server's just serving static pages out, you may not need any additional storage. You may not need it to be persistent. A database server, you certainly will do. And that way, if the server has to be moved by your service provider from one underlying physical host to another, that storage will persist and will be remounted onto the underlying systems that are hosting that. When you're deploying Linux servers in the cloud, the authentication is always done by an SSH key pair. So don't deal with passwords anymore. We don't have to worry about setting a root password or an administrator password. You'd be using an SSH key pair. And that then gets deployed at the time the servers come up and allows you to then use the key pair you specified at launch time to connect into the servers. Lastly, you say how many you want. So let's say I want to have 6 web servers. I said that I want them to be spread across the public A and public B subnet. When you hit go, it will round robin that request and it'll bring up 3 in each of those subnets. If you've got more availability zones, it will spread them around, and it's really powerful. And as we mentioned when we were talking about the concepts of elasticity and the resource pools, this can often feel like you've got infinite resources available to you. You can, really push the boundaries and say, I want to spin up hundreds of servers and just hit go and watch them starting to appear in your environment. And if you go to any like conferences and any meetups and things like that, quite often you'll get someone from one of the big service providers showing off and saying, all right, I'm on my Google Compute environment. I want to spin up 1,000 of these servers, and then hit go. And like 5 minutes later, you have this screen full of server names where it's all created. And it is often that simple. Last thing you need to think about is how you're going to expose that service. So if you've got multiple servers, you'll typically use a load balancer, and you don't need to worry about your F5s on premise or anything like that. Cloud providers have their own load balancers that you can use. So you can choose whether it's like a layer 7 load balancer, load balancing with an HTTP requests, with layer 4 where raw TCP traffic. All of these options are available to you. You can specify, if it's an HTTPS service, you can add an SSL certificate so it can offload the encryption and the termination of that HTTPS connection. You need to tie that in, obviously, to your domain names and add the subject alt names into that certificate. And you select which of the backend servers that you're going to send that traffic to. And again, this is done by grouping those servers together. If you increase the number of servers, the load balancers will know about it. And if you decrease it, again, it will shrink that target group down so it knows where it's sending the traffic to. Then you've got, logging options and things. Do you want to save your access logs? Where you're going to save it? How persistent are the logs going to be? Life cycles and so forth. So once you've done all of that, you want to monitor it. You need to monitor those deployments. You need to know how busy your servers are, and you need to be able to see how much they're being used, because you need those metrics. You need to know how many requests a second a web server might be hitting, how much disk IO that's resulting in, how much CPU resource is actually being used to serve those requests. Is the server that I provisioned too big? Is it too small? Do I need to change the size of them? You can then use those metrics to spot repeating patterns. It might be that the service you're providing has a very standard pattern during the working day where it starts off quiet, you get some peaks around the times where people might have break time, and then it gets, trends back down again at the end of the day. There might be weekly trends. It might be something which is busier at a weekend, for example. But unless you're recording those metrics into some suitable system, you won't ever know how busy your servers are. You can also then plan for any expected peaks. If you've got a sale coming up, if you've got Amazon Prime days, if you've got Black Friday, all of these kind of things where you're expecting peaks, you can then start factoring that into your environment, and you can estimate your capacity based on those metrics. You can see, given the size of server I've currently got, and this is how much load I've got on it, and this is how much traffic I'm actually routing through it, am I going to be able to handle these peaks? Very, very powerful tools and monitoring. And then also you've got things like load testing. So you can prove that capacity. You can spin up, because this is the cloud, you've got easy access to more resources. You can spin up a duplicate environment, a complete like-for-like set of servers, same sizes, same spec, and then put that under load. And you can actually prove that given the size, the t-shirt size of server that you've chosen, it can handle that peak that we're expecting to have on Black Friday. Or you've got a sale coming up and we know we can handle it. So without that monitoring, you're blind. But Better than that, when you've got that monitoring, you know when you're underutilizing that infrastructure, you can then take steps to reduce that t-shirt size. You might have said, well, I don't really know where to start. My on-premise systems have got 8 cores, they've got 64 gig of memory. I'm going to choose the t-shirt size that is similar to that. Maybe it's a 4XL t-shirt size. And then when you actually put that into the cloud and you start putting some traffic through it, you think, oh, actually, if I look at that last resource, there's very little CPU usage. The memory is not getting used. The lines are very flat with just a few little ripples in there. So what you can then do is you look at how you can reduce that t-shirt size, and then you'll pay less for it. Now, if you're using a legacy architecture, it may be that the only way you can scale that is by changing the t-shirt size down. That's fine. But you can then use those metrics to keep an eye on the usage of the scaled down t-shirt sized servers. And then you can keep an eye on whether you want to go down further or whether you want to actually maybe scale it back up again if things are starting to get a bit busier. If your application is a bit more distributed, then maybe you can think about scaling horizontally. And what we mean by that is adding more servers. So if you are load balancing your traffic across 4 servers and you see that they're starting to get a bit busy, maybe it's taking a bit longer for them to respond back to your customers and to display the web pages as you want them displayed, nice and sharp and snappy. Maybe what you can do is add an extra server or an extra 2 servers, which will then share that load out a bit more. And you can use the monitoring to model those thresholds and look at where those triggering events might be to cause the number of servers to scale. And most of these cloud providers have an option of auto-scaling your deployments. So you can say once maybe the latency on the network requests, or maybe the CPU load level gets above this certain threshold, then trigger a scale up event. And likewise, you want to model the scaling down event so it will scale back down and only charge you for what you're using. So there's lots of ways which you can just lift and shift and move your existing architecture into the cloud. But what we want to look at is how can we use the cloud better? And that's where we start hearing this term cloud native come along. So cloud native is all about changing the way you think about constructing your critical business systems. It's about designing the systems to embrace rapid change, to be able to scale very large and to be resilient. And as things have progressed, as times change, applications have become increasingly more complex and users demand more and more from them. They expect rapid responsiveness. They expect new innovative features and no downtime. And you often get performance problems and recurring errors and the inability to move fast. These are no longer acceptable to your customers. And if they get fed up, they'll move to a competitor. So cloud native is trying to address that. It's trying to give you a framework, a different way of thinking about your infrastructure and how you deploy your architecture, to think about it differently. And this is a quote which is taken from the Cloud Native Computing Foundation, where they're trying to define what cloud native means. The cloud native technologies empower organizations to build and run scalable applications in modern dynamic environments such as public, private, and hybrid clouds. Containers, service meshes, microservices, immutable infrastructure, and declarative APIs exemplify this approach. And we'll have a look in a few slides' time at some of that about containers and about the immutable infrastructure. So one of the key things there when we're talking about cloud native is speed and agility. And these systems, they're no longer just enabling your business capabilities, but they are key to your growth, key to your strategic transformation. And you need to be able to get those ideas out to market quicker. Otherwise, you're going to lose those customers. Now, I've been to a lot of presentations and people always show numbers like Facebook deploys so many thousand times a day. And I haven't put Facebook up here. I've picked three other customers, three other companies: Netflix, Uber, and WeChat. WeChat are a messaging and multimedia provider out in Asia, very popular in China. And some of these numbers, they might sound a bit scary and a bit daunting, and think, well, how can anyone do 1,000 deploys a week? I might be struggling to do 4 a year at the moment, quarterly releases. Well, yeah, but when you start breaking it down, when you start thinking in a more cloud native way and actually structuring your deployment pipelines and putting automation in place, it's achievable. I'm currently working with one client, and we've been working very tightly on getting their deployment pipeline sorted out and streamlined and more automated and efficient. And we took a stop gap at one point at the end of the sprint, and we just did a quick sum up of all the deployments that we'd done in that last week. And would you know, we had actually done just under 1,200 deployments in that week. You don't realize it, but it is very achievable to be doing the same sort of things that these big companies like the Netflixes, the Facebooks, they may be held up as the exemplars, but it's not out of your grasp. It's certainly achievable. And the way a lot of them do that is they use this 12-factor wrap as like the North Star, their guiding principles. You can look this up yourself. 12factor.net is the website. And they list 12 things which you should strive to achieve when you're refactoring, when you're designing applications to be cloud native. First thing is your code base. Each service should be stored in its own repository. It can be tracked with version control. It can be then deployed out to multiple environments. So you have one version for each of your microservices, not one version for your entire release. Within that definition of the service, you isolate all of its dependencies. And then when it comes to modifying your code base, you're not going to break something else. You're going to be completely isolated from something else that's running next to you. You can update the dependencies on just your code base and reduce that blast radius. Worst case scenario, you'll just take down your own one little bit of the system. Externalize your configurations. Take any configurations you might have hard-coded into your application out. Use configuration management tools to manage those configurations. And then what you've got in your code base within your versioned repository, you can then deploy that same version of code into every environment you've got, and then use your configuration management tools to just feed in that externalized configuration. And that makes it so quick, so powerful to have consistent deployments across your environments. Similarly, any backing services that you rely on, any databases, data stores, caches, message brokers, you expose them via an addressable URL, some link back to those services, rather than having it tied into your code. And then that way, if you need to swap out the service, if you need to upgrade the service, it's all interchangeable, and it decouples your little bit of code from the rest of the system. Having a strict separation between your build, your release, and your run cycles. And the key here is to be able to have uniquely tagged build artifacts. So you've got your code base, you version control your code base, your build cycle will then tag a snapshot of that code base and treat that then as immutable. And then every point going forward, as part of that release process and into your operational, your run phase, you've got a uniquely tagged build artifact that you can always go back to. And you can use it to roll back as well. So if you've done deployment, it's not working, you've got a uniquely tagged artifact you can then go back to as part of a rollback process. Make sure all of these processes run in isolation from each other. Externalize the state, use data stores, use Redis, use a backend database to externalize that state and keep your actual application, your executables, isolated from each other. And when it comes to exposing that functionality for other services to consume, expose it on its own port so that you're introducing an API first capability. Everything will talk via these ports rather than using internal memory copies or anything, which, you know, this is breaking down the big monolith into little isolated, decoupled services, which you can then handle in a much more agile and fast fashion. And once you've got them broken down, that concurrency allows you to then scale these processes a lot better. Because if you've got one bit of the system which is particularly overloaded, create a couple of copies of it. Have 5 replicas of the postcode lookup system running. Have 10 copies of the postcode lookups running. And then that can handle the increased lookups that are coming from maybe your ordering system that are trying to finalize that order process and put in the customer's address into the order system. But having it all broken down gives you that ability to scale out across a larger number of these small identical processes. Then we've got disposability. Still tied into this isolation of each of the processes, you want to aim that your processes have a fast startup so you can scale quickly, and you want to have a graceful shutdown so that any state is stored correctly, though if you need to scale up again, you can quickly pick that state up again. You don't have any inconsistencies you have to worry about. And we'll have a look in a minute. Things like containers, Docker containers, they are great for doing this kind of thing when you combine it with an orchestrator that can handle the starting, the scheduling, and the management of these processes. Key to going fast is keeping your environments consistent and as similar as possible. You want to avoid making any shortcuts to try and push your processes through, and keep those environments as consistent as possible, because if you have any differences, that will only prove to be costly later on, because you'll start having a deployment that works in one environment and then it will fail in the next. Logging. Treat everything that comes out as an event stream. You can then aggregate those streams. You can then pass them on to data mining, logging management tools, and long-term archiving of them. And the last one is admin processes. Keep your admin processes separate from the application. Any cleanup that you need to do, any reporting, analysis tools you need to do, run them as a separate process. Don't have it built into the application. Now, there's a book that was written, Beyond the 12-Factor Trap, by Kevin Hoffman, where he talks about all of these, but he also introduces 3 additional factors, which I'll list now just for completeness. The 13th is API first. Make everything a service. Use an API to interact with that service. And then if you need to put a user interface on top of that, it's very simple to use the same API that maybe a command line tool does, that a mobile client uses. Everything is then consistent and you're publishing that API. Telemetry, again, this comes back to monitoring. Collect those metrics, collect your domain specific, your health information, your system data, put it into a suitable tool where you can then graph and see the trends and see the patterns that come out of that. Because when you're in the cloud, it's not like running off your one server where you can actually run your deep level analysis and you can see system rules that they're making. You don't have that level of availability of the diagnostics tools that you might have when you're running on your own physical servers in your own data center. So you need to build that telemetry into your applications from the outset. And also build in authentication and authorization. Without that, you're going to struggle. You're going to have to then bolt things in later. So build that in from the outset. Implement identity into your APIs, into these systems, so you can authenticate your connections. Then you can authorize which ones are allowed to connect. And consider using role-based authentication, role-based access controls. And a lot of those cloud providers we mentioned earlier have this built into their environments. You can leverage that role-based access as part of your systems. We need to move on quickly. I think we've been talking a lot. So microservices, reference to services earlier. So when you're talking about microservices, you're talking about a distributed set of small independent services. And when you put them all together, that then builds your whole system. And these are some of the characteristics that you typically find in microservices. They implement a specific bit of functionality. They're completely autonomous. You can deploy them independently. You can, isolate that environment. You can even use different programming languages, different runtime environments once they're encapsulated in their own little storage environment. Uses a standard protocols to communicate between them. And when you put them all together, that is then your application. Compare that to your traditional monolithic approach, where you might have a web tier, a service tier, and a data tier. You can see straight away that using microservices, breaking your system down into these small consumable components, gives you a lot more agility. I won't talk about the monolithic approach. Everyone's probably intimately familiar with the concept of a services tier and interacting with your database through a services tier rather than going directly. Key thing here is that with your microservice, they hold their own data. There isn't any shared database. That database is unique to your microservice and allows you to then independently evolve your microservice without having to worry about a blast radius affecting any other parts of the system. And it allows you to then scale that one service. If it needs more resource, it needs more instances to be run. And because it's just one small part of your system, it reduces your costs. In the old monolithic approach, if you needed to scale your services tier, quite often that would involve a vertical scaling. It need a bigger t-shirt size server. You need to maybe double the amount of memory available for those services to run because it's running as one massive monolithic executable. But with a microservice, if you need more services to run for your postcode lookup, if you need something to do your stock checking lookup, you can just scale up that one small component of it without having to scale everything up and have underutilized resource then, because most of the rest of the system doesn't need to be scaled. Containers, but mentioned them earlier. Containers are a great way of packaging up your dependencies in your runtime into one immutable artifact. And this is really taking that 12-factor wrap and the way of isolating your builds and your runtimes and your releases process into this one artifact, which you can then feed into it your externalized configuration. You have consistency between the environments, and you have much better usage of your underlying resource. The difference between virtual machines and containers, I've got the little diagram here. The virtual machine has a lot more overhead. You have the hypervisor, which allows you to run multiple virtual machines, but each of the virtual machines has to run its own guest operating system. Whereas a container, it just shares a portion of the underlying host resources. So you don't need multiple full-blown operating systems. You don't even necessarily need a full-blown operating system. A lot of these containers are very reduced and shrunk down to just contain what they need to run the application. You've got container registries, which is where you can use a repository to store these images. As I said, each container shares a slice of that resource. And it embraces the dependencies principle of the 12-factor wrap. Last thing to say is that you can use containers on Windows as well. It's a more recent technology, more recent move, but you can containerize Windows workloads as well. But it's probably more common with Linux systems. I'm not going to say a lot about orchestration. When you've got a large number of containers, when you've got a cluster of containers, then you need a way of actually scheduling those containers, knowing where that container is going to run, which bit of hardware, which underlying host it's going to run on. And so your orchestrator will know how busy, how much resource is in use, how much resource is free, and it can decide which of those servers in your cluster it's going to run your container on. It will take into account affinity rules or anti-affinity. You may want to make sure 2 copies of your postcode lookup are running on completely different underlying hosts, or you might want to group things which need low latency together so they all run on the one host. The orchestrator will take care of monitoring of those deployments, and if one of them fails, it can then launch a replacement container. Likewise, where it's monitoring it knows how busy it is, it can handle scaling, it will handle networking interconnectivity between them, and service discovery, so you know how to connect from one system to another. Now, there are a lot of different container orchestrators, but in the same way that there was the Betamax and VHS battle, and there's a number of other technology battles that have happened in the past, really everyone uses Kubernetes nowadays. Kubernetes is the out and out winner, and there's lots of workshops, and I think we've already had one of the WeShape workshop series, which has taken a look at Kubernetes and how you can use that within your organization to deploy containerized microservices and to actually leverage that sort of infrastructure, cloud native deployments. Automation. So we're coming to one of the last topics we're going to, automation, and is not having human interaction, but to automate as much as you can. 12-factor app calls for separation between the runtime release, build, release, and runtime stages. And you want to get through that process as quickly as possible. So this flow diagram here has your delivery team working on some code, checking it into version control, and that will automatically trigger the build system to run some tests. If that fails, you get feedback going back to your developer. They fix the tests, that will trigger it to go on to the next stage. So there may be some acceptance tests that fail, gives feedback to your development teams. And so what you want to automate is that whole process, so that from the point that your development teams, your delivery teams make those code changes, commit it into version control, try and automate everything you can from that point onwards to give you that speed, to give you that agility, to be able to get those changes out into production environments to benefit your customers, to drive that value for your business. And so automation of this build pipeline is such a key thing. There's also automation of infrastructure. A term you'll hear quite a lot is infrastructure as code. That is a way of declaratively describing what you want your infrastructure to look like. So say, I want a server of such and such size with this amount of disk space, or I want to deploy this application with a configuration file that has these settings in it. As opposed to your typical scripted style, which says, go and start up this server, go and log on to this server, go and open this file and write these lines into the setting. You're going to trust the underlying system, whether it's the 4 that I've got on screen here, Ansible, Terraform, Chef, Puppet, or as many other tools which do similar jobs. You're going to trust them to know that if you say, I want a file with this setting in it, it knows how to create that file, how to open that file, and how to write to it. You don't need to put that level of detail into these declarative scripts. You just say, I want my server to exist with an extra 50 gigabytes of storage. I want to create this subnet in the environment that we're creating in the cloud with this network side range. And it knows how to then talk to that cloud provider using API calls or using whatever connectivity is necessary, maybe an SSH connection onto a server with a suitable authentication SSH key pair, to then do the work that's necessary to turn your declarative description into the real world. Then these declarative scripts can be version controlled, they can be code reviewed, and they can be stored alongside the rest of your application as a project artifact. Once you've got this description, you've got this infrastructure as code, it's repeatable, it's consistent. You can use the same scripting across multiple environments. So you have a repeatable environment where your development, your test environment, your production environments are all built with the same scripts, feeding in different configurations. So you have different network ranges and different number of replicas if you're in a production environment to in a development environment, but you're using consistent automated scripting. And that means you can rely a lot more on the resulting infrastructure. And the neat thing about infrastructure as code and all of these tools is its idempotency. It will only make changes where changes need to be made. That means if you've already got 5 servers with the right amount of storage on there, and you change your description, your declarative script to say, I want 6 servers, it won't touch those existing 5. All it will do is it knows it needs to create a 6th server, and it will launch it and it will spin it up and provision everything for you in exactly the same way as it did the first 5. And that is so powerful. Likewise, if you change your script, say I only want 3 servers, it knows it will leave 3 servers behind and it will clear down those extra servers that you might have, a 4th, a 5th, a 6th server, and it will release those resources back to the cloud provider and you're no longer pay for it then. Great stuff. There's an article written by Sam Guckenheimer called What is Infrastructure as Code? And he describes how teams who implement infrastructure as code can deliver stable environments rapidly and at scale. Teams avoid manual configuration of these environments and enforce consistency by representing the desired state of their environments via code. and just having that just means you can just go so much faster. You can deploy consistently. You can have guaranteed environments which are similar to each other. And when it comes to your testing, you know that if a test works in one environment, there's no reason it shouldn't work in another environment, which means it shouldn't work in production. So automation, not only of your deployments, not only of your infrastructure, not only of your testing, automation across the whole board. So key to cloud native and to be able to deploy things fast. So we're not going to dwell too long on DevOps and SRE. There are a number of other workshops that you can attend, a number of other videos you can download, which talk in great depth about DevOps. We've got a talk on SRE coming up in a couple of weeks' time, given by another one of my colleagues. We'll have more about that later. So I'm not going to spend a lot of time looking at this now. What I will say, a little bugbear, DevOps is not a job title. DevOps is more than a job, it's more than a role. You'll often use or hear the term CALMS used to describe what DevOps is. CALMS stands for culture, automation, lean, measurement, and sharing. And the first letter of that, the culture, is what DevOps is more about than anything else. Automation is in there. That's very key to DevOps, and all of the elements we've just been talking about: automating your infrastructure, automating your testing, automating your deployment cycles. That's certainly part of DevOps. But culture is a big thing, and it's something that is led from the top down. It's not lived by practitioners at the bottom of the stack, but then paid lip service from the top, from your CEOs and stuff. It's a top-down culture there. Lean is about maximizing your throughput, maximizing your flow, and the agility that you get from that. Measurement, again, monitoring, keep a record of everything that you're doing, how much value you bring to the system, how fast you're deploying things, how long it takes your builds to run, as well as your metrics around how much CPU, memory resources the servers are using. And the sharing element, that is a feedback loop. It's then learning from what you've done, learning from any mistakes, learning from any failures, learning from anything that's gone well, and using the measurement element of it, using that culture to improve and to be able to do things better and to go faster. You might also hear the phrase, the 3 ways used to describe the underlying principles of DevOps. Just quickly, the first way is talking about flow and how work moves in one direction downstream. So you'll start a process, you'll pass it down that pipeline, you might do a bit of work on it, you pass it on to the next person in the pipeline. But what you don't do is block that piece of work. You don't push it back up the pipeline. The second way is creating and shortening and amplifying feedback loops. So the diagram I had about the development teams checking in code, you're getting instant feedback from the initial unit tests, you get further feedback from failed acceptance tests and stuff. So that's looking at shortening and then feeding back on the flow to actually improve the throughput. And the third way is continued experimentation. And again, this ties into the culture of DevOps, being able to learn from your mistakes and to ultimately achieve mastery, to make yourself better, to go faster, and at the end result of that, deploying better customer outcomes, better value to your business. So DevOps is very much focused on delivery speed and quality and getting it right and getting things out there fast. And this is another diagram you'll often see used to describe DevOps. The more collaboration you have between different people, different teams, the more value you get. So DevOps is more than just agile development. It's more than continuous integration of that code base. It's more than automating that delivery and continuous delivery, but it's covering that whole range, going all the way through to the runtime, to the operating system. But with that feedback loop, the little loop at the top, feeding stuff back. Compare that to SRE. Well, SRE is more the operations end of things. It's still very much focused on automation, but as the term site reliability engineer implies, their focus is much more on reliability through automation, reliability through infrastructure as code, reliability through observability, through your monitoring, and be able to react better and to learn from any outcomes that you have from any failures, any issues, and so forth. So like I say, have a look at our coming website. There's a whole talk around site reliability engineering. It'd be well interesting, very, very worthwhile signing up for that one. And just finally, so there's a lot of overlap. DevOps, site reliability engineering, these are all very new terms. We're talking about within the last 10 years or so. But if you go back beyond that, no one knew what DevOps was. People did it. It was part of my job description 20 years ago. But the term DevOps, the term site reliability engineering, these are all very new concepts, and people are still understanding themselves what that means. You go into a room of 10 DevOps engineers, first of all, ask them what their job title is, what they do. Virtually everyone will be doing something different. Ask them what they understand DevOps means. You'll probably get 20 different versions because they'll hear the first 10 and then they'll change their answer. So, it means lots of things, but there's lots of overlap as well. And add into that cloud technologies, cloud native technologies. And what we're really talking about is being able to give you quality, consistent, reliable, and fast delivery of your ideas and getting that business value out to the customers and driving good outcomes. And that's automation, that's monitoring, that's having that reliability built into your systems. And lean. Lean is about increasing that flow, reducing your work in process, and amplifying those feedback loops so you go quicker and get quicker and get quicker. So to wrap up, just to recap on what we've looked at. So we looked at what the National Institute of Software and Technology, Standards Technology call cloud, the different characteristics, the service models. We had a look at how we can reduce costs, increase your productivity and availability using the cloud services. Infrastructure as a service is your most likely route to migrating from traditional infrastructure, but you might find there's cool to look at some of the other models. You could software as a service, look at the platform as a service. You might find there's a very easy migration to maybe ditching an on-premise Git repository that you've been running and consume something like GitHub or the Atlassian Bitbucket and consume that as software as a service. Monitoring, get those metrics into a monitoring system. Use those metrics to know how to scale your infrastructure down as well as up. And if you get the chance, redevelop your application. Think about what it means to be cloud native. Have a look at 12factor.net, look at all the information you can find about these 12 principles around what it takes to design and build a cloud native microservice type architecture and automate everything. Infrastructure as code, automating your testing, automating your deployments, so key. And at that point, I think we can open it up to any questions. Do we have any questions from any of our attendees?
Hey Rob, I haven't seen any questions come through just yet. But what I was going to suggest is if anyone does, is they can ping them through to you and I after on email. We'll get back to them after the workshop. That's good.
Sure.
Cool. Rob, can you go to the next slide if possible?
Sure. Okay. There's just one left in the deck.
Yes, amazing. Yeah, so like, firstly, thank you. Awesome workshop. Really informative, and hopefully everyone who attended found it very useful and of good value. Obviously, we're running these workshops on a monthly basis hereafter. So we've got another workshop coming up on system reliability engineering by another lead consultant, Andrew Southall, on the 21st of July. So if you scan the Q code, it will take you directly to the register link. But yeah, I just want to say a big thanks to Rob. And if anyone does have any questions or interested in kind of reshape cloud solutions, please do drop us an email and we'll follow up thereafter. Also, we've got a handout, haven't we, Rob?
We do.
Yes, perfect. So we'll send that around and we will get this uploaded on YouTube and all our social platforms. Yeah, thanks again and cheers for attending.
Thank you, guys.
Cheers, Rob.